In this video, we'll be looking at the power rule of logarithmic expressions. For the power rule, we only need b and m to be positive real numbers. There doesn't actually exist an n in this particular example, and b has to be, again, still non-1. So with this particular expression, we're going to look at log base b of m to the power of p. Now notice how p is not included in any of this information. P can really be any number. This is going to end up being equaling to p times log base b of m. So what's important to note about the power rule is that if I have a power on the inside of a log, it has to be on the inside. If it's not on the inside of the log, it's on the entire log, then this doesn't actually hold. But if that power is there, it can drop down in front to be power multiplied by log base b of m. This can best be seen in certain examples in regards to the simplification steps. But let's look at a couple of examples. For the first example, we have log base 6 of 3 to the power of 9. This thing is going to simply be the 9 comes down in front. Again, that 9 is on the power of the 3. The way that we would tell that 9 is not on the power of the 3 and the power of everything is that if there were a parenthesis here and a parenthesis here. So with the parentheses not existing, the parentheses are assumed to be around, again, 3 to the 9th, as a whole 3 to the 9th. So that 9 is sitting on the inside of the log, the 9 can come down in front, and I'm left with 9 times log base 6 of 3. We can try and ask ourselves what power of 6 gives me 3, and there is no nice number for that. We'd have to dip into the decimals, so that would be the expansion of that particular problem. Again, the question for all these are still expand. The next one we're going to look at is the natural log of the cube root of x. Keep in mind that a cube root is nothing more than a fractional exponent. So our first step in this is we have to rewrite it. So it's the natural log of x to the power of 1/3. After rewriting it in that form, then we can drop that 1/3 power down in front of the natural log of x. And again, you'll notice how by manipulating this particular expression, we get down to this, where hopefully when we're asked to solve an equation that might look like this, or might have some expressions that look like this, getting it to be just the natural log of x might be a smooth move to manipulate. Lastly, we'll look at the log of x plus 4 to the power of 2. Now, it's really important to be very careful with this example. The reason why is because that 2 can drop down in front, again, because it's everything in here. If there's no parentheses anywhere, then that 2 is assumed to be just on this piece, and that piece is inside the log function, so it's technically log of this whole thing. That 2 can drop down in front. Again, I have log of x plus 4. Now, the point that I'm going to make here is that this is not going to be a quotient or a product rule case. The plus sign is sitting on the inside of a log, and I want to make note that that plus sign on the inside of a log does not follow the product rule. The product rule says a multiplication has to be on the inside for it to separate into two separate added log functions. So in this particular case, we can't do anything with that x plus 4. There's no additional steps to do anything with that, so that is utilizing the power rule to expand the particular problems that we see here.